Well, by now, I hope you've built up some real proficiency in the use of Minitab, understanding how to get the data in, how to use the functions, and how to read, interpret the outputs, and then how to convert those outputs into useful decision making by senior management. What we're going to talk about now is the last of the Minitab lectures for this Greenbelt series. And we're going to go back to this idea of statistical control. Remember, we began with eye charts. We didn't start with X bar R charts or X bar S charts, both of which are using sampled data. And the reason is, in today's processes, what we worry about is we want those processes to be operating ever faster. So when we use those sorts of sampling systems, whether we're taking 5 samples at a time or 10 samples at a time, that's really the only difference between X bar R and X bar S charts. What we start seeing is that that collection of samples itself will do 2 things. Number one, it'll delay our detection of change. One of the reasons that it delays that detection of change is the second thing that's sort of a negative against those types of charts, and that is by averaging, we have the averaging effect. So we start seeing not the limits of the individual observations, but we start seeing the averaged effect, or the 50 percentile of the functions of change. And what that means is individual observations may indeed be out of the boundary of the performance. Now, remember, in a control chart, we're looking at control within limits. Those are the control limits. We have to set the process up using our process capability analysis so the specification limits are well outside that. So even if we do have excessive variation in the control limits of the process, that we don't jeopardize the specification limits of the process. Now, let's take a look at Minitab and see how we can use individual charts, in particular how we can add reference lines for specification limits, and how we should have a discipline of determining stages in process performance so we have set demarcations when we change a process in ways that might be interesting for us to analyze. So we'll come back now and let's take a look at the Minitab function for individual charts. Okay, we have now come to the last of the Minitab modules, and what we're going to talk about is statistical control charts. And we're going to come back to this idea of the variables charts and the variables and moving range charts. So this is called the Imr chart. Okay, and so the Imr chart is a special type of variables chart. So we've seen variables data before, and we understand what is happening, and we can also understand what is going on in the process. So under these Imr chart options, what we'd like to do is say, what tests do we use? So now that we're talking about control, I'm going to perform all the tests. Now the reason we perform all of the tests here is we're also interested in patterns affecting the process that show within process performance. When we were taking a look in the measure phase, we were just using the first test, which is for excessive variation. The other tests here deal with pattern variation. It can be oscillation in a process. It could be a shift or a trend. It could be excessive variation, but within the performance limits or the outer control limits. So it's within distribution, excessive variation, which is talking about the data in terms of it not actually being normal. Another thing we might want to do, and this data set isn't set up for it, but under this Imr options, we might want to have stages set. And here what we would do is we would define a variable column where we see shifts in the process. So maybe we would be changing for new lots of material, for instance. Maybe we would change for frequently reporting processes by a function of the shift. So we see how different operators or different shifts affect performance. So any of those variables that would be interesting to us in terms of being able to distinguish this would give us then these different rational subgroups we saw by the time dimension for recording. So we're not setting that up here, but we are going to set this up in terms of this Imr chart. So what happens is we've got this data chart. And we see that we have some data here, okay? And as we're looking at this, what we start seeing is I have some distribution data. Now, as I'm looking at this eye chart of the information here, I see here is the performance variable, and I see a chart 6, symbol 6 here, and saying observation 10 is failing a test. Now I take a look at this, and it is too many pieces of deviation too far from the mean. Okay. Here it's test number 2, and here it's test number 6. Here it's test number 1, excessive variation on the moving range. And so as we're looking at this data, we start seeing there is some pattern deviations. Now, we don't worry too much about these in the middle unless it gets really locked on the line. And by locked on the line, I'm talking about this test 8, so much tight that there's not enough variation in the process. Not enough variation can be an indicator that the measurement system isn't working right, or it got stuck, or maybe the process is not recording properly. So as we look at these, we see here on this moving range, we really care mostly about the excessive variation tests. And here, if there's a trend going up or a trend going down, 7 points in a row, we would start seeing that there's a concern. And that might be that it's showing us that it's going to move outside the upper and the lower control limits, and therefore that the process is moving out of control. Now, one thing to remember when looking at these particular charts is that if we have two parts broken up by a third, that it doesn't register as this test. I have to have all 3 in a row going down. So there's 1, 2, 3, but I need 4 more to show that there's something going down. Here I have 1, 2, 3, but I would have to have a 4, and it's not saying that I'm actually getting a trend of down, even though I look at those major shifts happening as potentially a trend going down. So again, we have to take a look at the tests, and we have to understand what's happening in the process to see what's going on. Okay, if I want to add a reference line, the reference lines can be very helpful. So let's just say I'm adding a reference line at 608 and at 594. Okay. And so I say, okay, there's something else happening there, so I've added those reference lines. Now, I didn't show this one here because this scale is not off. Okay, so the scale goes to 595, and so I have to actually change the Y scale. And so what I want to do is I want to change the minimum, and so I'm going to change that to 592, for instance. And now I can see this. I don't see 594. So let's insert reference line. Now I see the 594. Okay. So now if those are the specification limits, I see the spec limits are outside the control limits. The grand mean is here. So all of these pieces of variation are not actually hurting me in terms of nonconformance with the specification. So again, for management, I probably want to then tell them I'm going to edit that label. And so I come down here and let's call that USL is equal to 608. So that says upper specification limit. And then edit this label. And that is LSL, or lower specification limit. So now we see we're still making good products on this process, but these improvements in here might actually help to improve the consistency of the product within there. So if we have some product performance consistency issues, it might be saying we need to tighten up the control of that process. Notice how the process was running very tight in here, and all of a sudden it got loose. So again, we're not seeing that actually in terms of the data, but it's helpful to take a look at. Again, we probably don't want to call this an Imr chart, and so what we want to call this is a process behavior chart. And we don't want to call it individual values. So we would probably want to call that something like measurement. So we can actually put the name and observations. We can call it observation, or we can call it time, or whatever. So again, treating the data so that we can show it and describe it in a way that is meaningful to management is what we would like to do. So again, the process now, we're transitioning it to the state of control. How do we manage the process to make sure it's delivering what we want it to do? This individual's control chart is a critical chart for us to understand what's going on. This chart, coupled with the capability analysis, which describes how consistently we meet that performance, are the two that really will tell us, is the process operating in a way that's delivering what customers want, the capability analysis, and is that process operating in a way that is consistent over time and gives us the lowest cost process in terms of maintaining consistent outputs, and that's the individual's chart. So take a look at this data or your process data on your Greenbelt projects that you're going to be doing. And remember, this individual chart is probably one of the most flexible tools that you will have in terms of understanding what's actually happening in the data analysis world. Now that we've done this, what you see is we have actually come to the conclusion that we had in the beginning of the exploratory data analysis. We've now looked at individual charts, we've looked at process capability studies. As we add those process performers step by step across the process, we have a one-way ANOVA. And as we identify all the things gone wrong, we can have a Pareto chart. And if you remember back to exploratory data analysis, those are the 4 charts in the exploratory data analysis. So the conclusion I want you to draw is, if we're using those charts properly, the charts that we had in exploratory data analysis, when we're looking totally uncontrolled at the process, are exactly the charts we can use in the daily monitoring and management of the work process of our normal daily work routine.